Hi students, we have reached to the final video series of second unit. In this unit, we are going to discuss about series and parallel connection, otherwise cascade or parallel connections of linear time invariant systems. If you consider any of the electronic devices which you are using on a daily basis like your smartphone, your television or any other gadgets, you can see that these systems are not designed at once. These are designed and manufactured as small units and they are connected together. For example, camera will be from Samsung and the touchpad will be from Apple and the display will be from Videocon. So different companies are contributing to these parts and they are connected together, though they are assembled together to form a complicated device. In the case of softwares, nowadays softwares are designed as open source project and people at different parts of the world are sitting together and creating small modules of the software and we are integrating them together. There will be an architect, software architect, hardware architect, he will be connecting everything together, right? So in the same way, LTI systems are also not analyzed or synthesized at once or as a together single complicated system. We are dividing them into small parts or small subsystems and then we are connecting them together. When we consider the interconnection of LTI system, there are two types of interconnections possible. We are studying them from the high school itself. What are the two possible connections of resistors or capacitor or inductor? We know that they are parallel connections or series connections, right? We call it as parallel and cascade connections. Here also, in the case of LTI systems, we have two kinds of connections possible when we take the subsystems. We can either connect the subsystems in a parallel manner or we can connect the subsystems in a cascaded manner. Now when we connect the systems in parallel or cascaded manner, what happens to the impulse response? What happens to the overall impulse response? How the impulse responses of the individual subsystems will interact together when we connect them in parallel connection or series connection. That is what we are going to see in this video series, right? So first video we will give a small introduction about the parallel connection and series connection. Then we will go for the detailed analysis of the parallel connection and series connection and some applications of these parallel and series connections of LTI systems, right? At the end of this video series, you will get a clear idea about the parallel and cascaded connections of LTI systems, how to analyze them, how to synthesize them, what are the beautiful results which we can create from these interconnections.
A larger and more complex systems can be often viewed as interconnection of several smaller subsystems. Each of them will have different characteristics and we can combine these characteristics to predict the behavior of the overall system, right? So if you know the characteristics of these subsystems, then it is very easy for us to analyze the behavior or the characteristic of the larger system. That is the basic idea here, right? So generally there are two different types of interconnections. They are parallel interconnection and series interconnection, right? So here we are considering the parallel LTI interconnection and series LTI interconnection, right? Assume that we are giving an impulse signal del of t as the input to this parallel connection. So what happened? This path will be divided into two here, right? So this is a parallel connection. So del of t will go here and del of t will go here. So this del of t and del of t is going into the system. Now coming to the system, so let us call this system as S1 and this system as S2. And what happens? We know that whenever we provide input del of t, that is impulse signal, right? So this is impulse signal. So whenever we provide an impulse signal into a system S, let us say this is a system S, it will provide us impulse response, right? So it will provide impulse response, which we have already discussed, right? So let us say that H1 of t is the impulse response of this system, that is S1, and H2 of t is the impulse response of the second system, right? And the properties from the analysis, people found that this is having a peculiar property, that is the parallel connection, right? The impulse response of the overall system is equal to H1 of t plus H2 of t, right? So if we consider the entire system, right? So if you consider the entire system, this entire system as a single system, right? If you consider this entire system as a single system, you can see that we are giving an input here, right? We are giving an input here and we are getting some output here, right? We are getting some output here, right? Actually, that output is nothing but the summation of the individual outputs H1 of t and H2 of t. So this is the basic idea of parallel connection of LTI systems, right? If you connect the LTI systems in parallel, we have to add the impulse response of the individual systems to get the output, that is HP of t. The parallel connection impulse response is equal to H1 of t plus H2 of t. So that is the basic idea in the case of a parallel connection. So this is SP, that is a parallel system, entire system as a single system. If you can express the entire system as a single system, let us call it as SP. Actually SP is a parallel connection of S1 and S2. So its impulse response will be added in the output. Now what happens if we connect in series? So let us consider the series connection. So again assume that we are providing del of t as the input, and this is our system 1 S1 and this is our system 2 S2. They are connected in series, and together we can call the series system, right? So together these two can be called the serial system. So let us call as SS, right? Serial system, right? Serial system or cascaded system. We can also say cascaded system, right? So this is series LTI connection or cascaded LTI connection, right? So what happens at the output is that from the analysis we can see that H of t, that is the overall output of the system, will be equal to convolution of H1 of t and H2 of t. Convolution of H1 of t and H2 of t, right? So where del H1 of t is the impulse response of S1 and H2 of t is the impulse response of the second system S2, right? So I have to keep it here, right? So H1 of t is the impulse response of the system S1 and H2 of t is the impulse response of the second system, right? The effect in the output will be equal to convolving H1 of t and H2 of t. So this is how the impulse responses will interact when we have systems connected in parallel and cascade. So this is how the parallel connection impulse response and series connection or cascaded connection impulse response will behave, right? So in parallel connection the impulse responses should be added, and in the series or cascaded connection the impulse response should be convolved, not multiplied. So we have a tendency to say the word multiplied. Please keep it in mind that it is not about multiplication, it is about convolution. We have to convolve H1 of t and H2 of t to get H of t, which is the output of the cascade system. So let us explore this further in the upcoming videos.
I hope you got the mathematical results of series and parallel connections of LTI systems. So this will be useful for you to solve so many problems which you face in the subject signals and systems.